Hexagonal architecture, also known as ports and adapters architecture, is a software design pattern that aims to create a highly decoupled and testable application by emphasizing the separation of concerns between the core business logic and external concerns such as databases, user interfaces, and frameworks. The key concept in hexagonal architecture is the use of ports and adapters, hence the ports and adapters name. Ports are interfaces that represent the entry points into the core application. They define the contract for interactions with the external world and represent the application's use cases and boundaries. The core domain exposes these ports, allowing external concerns to interact with the application in a standardized way. Adapters implement the interfaces or ports defined by the core domain. They serve as the bridge between the core application and the external concerns. Adapters are responsible for translating the language of the core domain into something that external systems can understand, such as data persistence mechanisms, APIs, or user interfaces. This architecture revolves around the idea of dependency inversion, which means that high-level modules, such as the core module, should not depend on low-level modules, such as those external concerns. Instead, both should depend on abstractions known as ports. This inversion of dependencies enables the core to remain independent and isolated from external systems, making it easier to test, maintain, and adapt the application. Some benefits of hexagonal architecture are decoupling. This architecture promotes loose coupling between the core domain and external concerns, allowing changes to occur in one area without affecting others. Testability. By defining clear interfaces, or ports, for interactions, it becomes easier to test the core domain in isolation without relying on external systems. Flexibility. Hexagonal architecture allows for the replacement or modification of external concerns or adapters without impacting the core domain, making it more adaptable to different technology stacks. Isolation of core domain. The core domain is the focal point of the application, enabling developers to focus on expressing business logic without being influenced by external factors. And lastly, domain-centric design. This architectural pattern encourages a strong focus on the core domain and the business rules, leading to a more expressive and maintainable domain model. If we look at the following diagram, we can see that the traditional three-tier architecture with controller, services, or business logic, and data access layers have all the arrows pointing to the right, indicating that the flow of control is from the left to the right. But what if we invert the dependency between the business logic and the data access layer? The business logic layer will still interact with the data access layer, but it will do so through an interface or port. This is the core idea behind hexagonal architecture. The business logic layer is isolated from the data access layer and vice versa. The business logic layer defines the interface or port, and the data access layer implements it as it is our adapter. So to summarize, hexagonal architecture focuses on a strong separation of concerns, dependency inversion, and clear interfaces known as ports for interactions. It promotes a domain-centric design and provides better testability and flexibility. On the other hand, three-tier architecture relies on horizontal layering, but might not achieve the same level of isolation and testability as hexagonal architecture. The choice between the two depends on the specific requirements and complexity of your application. For smaller applications, three-tier architecture might be entirely sufficient, while hexagonal architecture is typically more suitable for complex applications that require an even more decoupled and domain-centric design.